Okay, so I am Suraj Borate. I am NPTEL TA for Introduction to Robotics uh, course, and we are in the final week, week 12. Um, and today we will be covering questions related to the localization and path planning topics. And so the aim of this tutorial is to help you solve the week 12 assignment, and the week 12 assignment and the previous year questions are the same, and so I won't be giving you the answers directly, but for every question I will discuss the options enough so that you will be able to solve the questions. And if you have any specific doubts, then we can take that up also. Okay, so let's start. uh, okay, so the first question is, which of the following can be used for position tracking? So only we both are there in this thing, so when I ask, then you should answer. Okay, so which of the following can be used for position tracking? Kalman filters, extended Kalman filter, particle filters, uh, binary based filter with static state. What do you think? So what is position tracking? What is a position tracking? So suppose there is a moving object that is in motion. Okay, and you want to know the position of this moving object as accurately as possible, and you have some sensors to find its position or velocity or something like that, right? That object is a moving object, right? So then you can use estimators like Kalman filter, extended Kalman filters, and particle filters, or can we use base filter? So, like, this is the question. Okay, so one of these or multiple of these are not possible to use, right? But the key here is that the position tracking assumes that the object is dynamic. Okay, fine. So accordingly you should be able to answer this. Okay, the state of the object is changing, and with the changing state you are trying to estimate the position. Okay, in position tracking. So in like some of the option or one of the option might not allow the dynamic state change. Okay, so that is more than enough hint. Okay, you can hear my voice, Sujay?
Yes, sir.
Yeah. So what do you think the answer is for first?
Sir, I think answer Kalman filters, extended Kalman filters, particle filters. Both three.
Okay, okay. And why not D? Because it is static state, right? Something like that. Hello, hello. Can you hear
Yes, sir.
me? Okay, okay. So let's go on to the second question. Particle filter can be designed to recover from an erroneous belief distribution. Okay, is it true or false? Okay, so if you remember the particle filter that we have discussed in earlier weeks, in particle filter we had the resampling step, right? Resampling step in which new particles were added, right? So these new particles, when they are added, right, there is something that happens. Okay, if you study the resampling step of the particle filter. Okay, what used to happen in resampling step? Do you remember particle filter? Hello, hello.
Sir,
Anybody?
not remember.
Okay. So in the particle filter, there was a resampling step. In the resampling step, you add new particles. Okay, and in that when you add new particles, if your earlier if you have some earlier bias, that bias can be overcome. Okay, and if you study that resampling step, then you should be able to answer true or false for this question. Okay, so that is the hint. Okay, so you go to the slides and you visit the particle filter resampling step. Okay, Markov localization algorithm is computationally more expensive compared to the Kalman filter. What do you think?
Sir, I think true.
Why? What is the thinking? Be-
Because Markov localization uh, has position tracking,
Hmm.
this mass distribution, and partial knowledge, global localization.
Hmm. Okay. See, okay. So, see, position tracking can be done with Kalman filter also, right? So there is something different over here. Okay. So if you see Markov localization and Kalman filter, in Kalman filter you see that what what states are being updated. Okay, and in Markov localization you see what states are being updated. In which of the algorithm more states are being updated. Okay, so if you see in Markov localization, for every cell of the environment you need to find the probability or the uncertainty. Okay, and you have to compute the like the updates. Whereas in Kalman filter, what we are doing, that you have to see and compare that way. What are the states and what are the operations? Okay, if you see both the algorithms side by side, the answer is pretty obvious, and even from my statements, you can find the answer. Okay, it basically in in Kalman filter, you are just updating the state of the robot, right? Or the interest, whereas in Markov localization you have to update states for or you have to update probabilities for every cell. Okay, now let's move on to the this question, fourth question. Markov localization can address the kidnapped robot problem. What is kidnapped robot problem? Can you explain me? Okay, kidnapped robot problem, do you remember? Okay, so in kidnapped robot problem, what happens is the robot is some localization algorithm is working on the robot already, and the robot is able to also has the map and everything it has. But suddenly what we do is we pick up the robot and place it somewhere else, and the robot continues to believe that it was in the original position. Okay, so that is the kidnap robot problem, and such such robot has to recover from its belief which is wrong and get the correct belief. Okay, the reason, okay, so what it is saying, the assertion is saying that Markov localization can, okay, someone is joining. Okay, no one joined. Okay, fine. Uh, so the assertion is that marker localization algorithm can address the kidnap robot problem. And the reason is that marker localization algorithm uses both map and the current observation to update its belief about the state. So basically it is saying that it is not only using its current observation but also the map. So it is saying if it gets lost by looking at the map and the observation, okay, how things are looking around me and comparing it with the map, it should be able to recover or solve the kidnap robot problem. So this is the reason it is giving. So very simple, you just have to look at the inputs for the Markov localization problem. Obviously map is there and the observations are also there. Okay, and okay, so you should be able to solve this question. Is it clear? Hello. Okay. So which of the following are true about the breadth first algorithm? Okay, so here are the options. It assumes that the edge weights are equal. It is a complete algorithm. It finds the shortest path given the source node and all other nodes in the graph. It explores all the nodes at the same depth level before moving to the next depth level. Okay, someone is joining. Okay. Yeah. So, which of the following are true about the breakfast search? It assumes that edge weights are equal. It is a complete algorithm. It finds the shortest path between a given source node and all other nodes in the graph. It explores all nodes at the same depth level before moving on to the next depth level. So, can you answer this? Anyone? I cannot tell you the right answer because these are the questions from your current assignment. But if you cooperate and try to answer, I can correct your thinking and guide you to the right answers. Okay. So speak up. What do you think is the right? Have you studied about breadth first? So okay. So breadth first is something like the option D, right? So you first move along the breadth of the graph before going inside the depth. Okay. So suppose okay, let my pen tab is malfunctioning. Let me just try to suppose this is the graph, something like that. So what breadth first does is it covers the this nodes first. Okay, so it goes over here, then it covers this node before going depth to the deeper nodes. Okay, so this is the breadth first search. So first option is it assumes that the edges weights are equal. Okay, so if edge weights are equal means that here if it is 1 then this is also 1, means all weights are same, like okay. So there are okay, so there is breadth first, there is Dijkstra, and there is A star algorithm, right? So in breadth first algorithm, this is an unweighted algorithm, right? So all edge weights are equal. Then in Dijkstra algorithm, their edge weights can be different, but this is best first algorithm. So it whatever cost is the lowest, it will go to that node first. And A star algorithm uses heuristic also. Okay, so it is like not the best node also includes the heuristic. Okay, so how much distance is remaining to reach the goal and how much distance it has traveled yet. Okay, so both things are considered in A star algorithm and we will see an example at the end. Okay, so what do you mean by a complete algorithm? This word complete. Okay, So a complete algorithm means that if there is a solution that exists, then you should be able to find the solution. Your algorithm should be able to find the solution. Okay, so whether breadth first search is a complete algorithm or not. So if the path exists, then you should be able to find the path using breadth first search, right? If the path doesn't exist, then you cannot find. Okay, does it find the shortest path? Okay, these are the
No,
questions
sir.
that I asked. Anyone? Hello?
No, sir. First not found.
Not shortest path. Are you sure? You should check. Okay, check this thing before you answering this. Okay, breadth first search whether it finds the shortest path or not. Okay.
Yes, sir. Yes, sir. Shortest path find.
Uh, so just check. Okay, I cannot answer because this is the current question. But yeah, so I have given you enough hint. Okay, so just put my laptop on charge. Okay, so let's move on to the next question. Okay, so the Dijkstra algorithm can find shortest path between a source and a target node with arbitrary edge weights. Okay, so Dijkstra algorithm uh, can have weights different, right, or wrong. Okay, and at each visit to a node, Dijkstra algorithm tries to update the minimum distance to reach the node from the given source node. Okay, so at each visit to the node, so whenever it visits the node, it tries to update the minimum distance to reach that node from the given source node. Okay, this is again the algorithm related question. Okay, and one hint I can give you is that first statement is true. Okay, this first statement is true. Whether the reason is true or not, that you figure out. Okay, so that will help me not give you the answer, but at the same time give you some hint. Okay, the seventh question is an important question. Okay, and this kind of questions you should be expecting also, and this can be asked for any type of algorithm, not just A star. Okay, so what they are saying is select all admissible heuristics. I don't know if you can read this. I will make it bigger. Okay, select all admissible heuristics from the options provided below. Using each of these admissible heuristics and the information provided in the table below, use the A star search algorithm to find a path from start to goal state for the grid world shown. And you can take g of x to be the number of steps taken to reach the grid cell x from the start state. Okay, so how much distance you have traveled from start state to the state x. Okay, and assume that the robot can move only adjacent, so it can move up, down, left, right. So and these are the options for the heuristic h of n. Okay, so this also you should choose smartly. Okay, so what heuristic, so what do you mean by heuristic? Heuristic is something that is our choice and we have to choose it wisely. Okay, so heuristic means that, so for A star typical heuristic is that from the current state to the goal, how much distance you might have to travel. Okay, so that is the kind of heuristic. Okay, so if you see all these three options, okay, first one says that start to the current position, so this is same as the g of x. Okay, this is actually your g of x. Then he is saying the g of x minus the start to goal distance. Then the second stage is saying that distance between start and goal. So start and goal minus g of x. So which of the three statements we should use as heuristic? That is the first decision you have to make while solving this problem. So can anyone tell me that which is the right heuristic? The aim is to find the distance to the goal from the current position. What is that? So this is the answer, right? This one. So you have to, from start to goal, how much distance is there minus how much you have already traveled. Okay, that will be the distance to the goal, remaining distance. You are getting?
Yes, sir.
Yeah. So here they have given distance from start state to every grid cell. So they have given g of x. Okay. From this you have to find the h of x and make a table like this. Okay. You can make a table like this for h of x. Okay. I will not make it for you. You can make. Why you can make? Because you know start to goal distance, right? This is the goal point, right? See, they said goal is here. So this is the goal point. From goal, if you subtract all these quantities, 4.2 minus 0, 4.2 minus 1, 3.2, like that. Okay, and you fill in this here, then you will get heuristic for each state, right? And once you get heuristic for each state, what do you have to do? What is the next step? You know the heuristic, you know how much distance it is from the start state also. Okay, now what will happen is, what is the thing that A star uses to take a decision? Okay, so it is f of n. So f of n is equal to g of n plus h of n. Okay, so you know g of n, you know h of n also. Any n, let's say I am telling any node. Okay, that is particular node number. Okay, so what you have to do is, this is the hint. Okay, name is this 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. You name something like this. Okay, and then create a graph. From 1 you can go to 2 only, right? Adjacent. From 2 you can go to 3 and 4, right? From 3 you can go to 5. Okay, from 4 you can go to 5, right? From 4 you can go to 7,
7.
right? From 5 you can go to 6, from 6 you can go to 8, right? From 7 you can go to 9, from 9 you can go to 11, 10, right? And from 11 you can go to 12, and from 8 you can go to 12. Okay, you create a graph like this, right? And then, okay, where is my cursor? Yeah, then what you do? Then you fill in the g of n values, the h values, how much distance you have traveled till now. Okay, so basically what you do is you open a list. Okay, I will not solve the entire algorithm over here. Okay, so what I can tell you is, this is the hint. You create the graph first, and Then you apply the algorithm. So this is the graph. This is how you get h of x. If you once you get h of x, for every step you can compute f of n. Okay, g of n plus h of x, g of x plus h of x you can do, and you can get f of x. Okay, and then you choose the minimum f of x to like to add the node. Okay, so let's say you start from 1, then obviously go to 2. From 2 you have two options, 3 and 4. Okay, so now 3 and 4 are under consideration. 3 and 4. For 3, whatever is f of x you calculate. For 4, whatever f of x is calculate. Whatever is minimum, you go to this. Now you don't throw away 3. Okay, you keep 4. Okay, from 4 now you can go to 5 and 7, right? Okay, for 5 you calculate f of x, and 7 you calculate f of x, and for 3 you calculate f of x. Now whichever is minimum from 3, 5 and 7, you go there. Okay, like this, you if you do, let's say we get 3 minimum. Okay, then what will happen? We'll go to 5 only again. Okay, now again after going to 5 we have how many options? 6. Okay, just 6, 7 is there. So we will check again f of x for 6, 5 and 7. What is minimum? Let's say 7 is minimum. Okay, you go to 7. Then you have 9. Okay, 5 is done, 6 and 9 are remaining. Okay, so like that you do. Once you do that, so this is not the answer, this is just I have not used the values. Okay, when you do this, okay, one time you will reach the goal. Once you reach the goal, you stop. Okay, along the way, how many nodes did you visited? Like I visited 2, 3, 4, 5, 6, 8, 12, something like that, or 7. Till 7 I came here, and then from here I went. So 1, 2, 3, 4, 5, 6, 7, 8, like that I will count how many nodes I have visited. Okay, because that is the question. In real life, once you need the reach the goal, that is done. But here they have asked the question, how many cells does the A star search visit to find the goal state? Okay, so when you apply A star over here, so how many options you had considered? Okay, 1 to 2 you went, then 4 you went, then 5 you went, according to the algorithm. Okay, where you minimize f of x, you will count that and you will write the answer. It is one of this answer. Okay, so let's move on to the next question. Okay, where are the next questions? Okay, I will just check if there are any other questions, then I will add if required. Okay, these were the questions only, I think. So I want to take up your questions if required. Like if you have any questions, then you can please tell me. Hello, can you hear? Hello,
Sir,
yeah.
sir, this question only if possible. Any random numbers, please. Means
Okay,
we need. I have got but if any random numbers with one example will be more helpful,
Okay,
sir.
I will create a graph and we will do that. Okay, with random numbers. Not this graph, new graph I will create. You know now know how to create the graph, na?
Yes, sir.
Right? So
This process, yeah.
I will take a
Uh,
smaller graph and I will solve. Okay, let's say this is node A, is node B, node C, node D, node E. Okay, like this. So E is the goal state. This is the goal, or I will call it G. Okay, and A is the start node. And let's say the edge weights are 1, 2, 3, 4, something like this. Okay, and let's say this is 1. Okay, so now what we have to do is we also have been given that A, B, C, D have the following h of x value. Okay, let's assume that the h of x value for node A is 4, node B is 2, node D is 1, sorry, node C is 3, and node D is 1. Okay, so now this h of x value in your question is actual value. Okay, actual distance remaining to the goal. But h of x is heuristic. We actually never know what is the distance remaining to the goal because we haven't visited the future or the forward path. Okay, and so uh, if we have map then we know, but if you don't have map then we haven't visited that. Okay, or even with map, okay, it may not be accurate, so we don't know. So heuristic is just like a guess. So here are some of the guesses given. So it is like when you are going to a railway station and you are in a new place, you just know that railway station is towards the east and you start moving towards the railway station. You don't know what are the obstacles that are going to come in your direction. Okay, but you know that okay, approximately it is 2 kilometer away from here. Okay, so I will assume my heuristic to be 2 kilometer for my current position. Okay, but when you move forward you come to know that okay, there are a lot of buildings in between, so I have to take left turn or right turn. Okay, so your heuristic is wrong, but at least your heuristic tells you that for your particular state how much far the railway station might be. Okay, similarly here they have given us this heuristics, so that guess thing they have given, and in your question also we computed the heuristic, okay, over the new table, okay, by using the one of the uh, heuristic that they have given, and that hint I have already given which one you should use. Okay, now here we have given the heuristic 43231. Okay, now we have to find g of x, that is the distance traveled till now, distance traveled till now. Okay, till now is very important. This is very important. Don't make a mistake in this question while calculating g of x. So till that particular node, how much distance you have traveled from the start node, that is the distance. Okay, and h of x is the distance, how much distance is remaining to the goal, and that you have to find over here. Okay, this thing that we discuss is h of x. Okay, now what you do is you open the list. Okay, you are in A, currently A, and you have two nodes now, B and C. Okay, for B, what is the value of g of x? G of x is 1. Okay, and h of x is 4. So f of x will be what? G of x plus h of x. Okay, so it will be f of B will be 4 plus 1, sorry, 1 plus 4, 5, right? Understood? Can you see the screen and
Yes,
understand?
I
Yeah,
can see. Means this
yeah,
h of x is we have given that 4, we are taking that one, sir,
yeah, that only. So h of x is, you should know it already
which
before
is before.
starting the A star. Yeah. Okay, so it
Okay.
is like a guess. Okay, and those guesses are given for every node. Okay, and here in the question we are computing the guess. Okay, using the metric that they have given, the formula they have given. Okay,
Okay,
we're
sir.
choosing the right formula and then computing. Okay, then
Okay, sir.
yeah. So for f of c, what will be f of c? Can anyone tell? F of c will
G
be
of x, uh, G of x is 4. So G of x
g of x is 4. Are you sure? G of x is 2, na? G of x is,
reverse. Yes, sir. G of x
yeah,
is 2 and h of x is 3.
yeah. So it will be 5, right? 2 plus 3, 5.
Yes.
Okay, now both of them are equal value. So you can choose any one of this. Okay, so you
Okay, sir.
choose, let's say you chose B. Okay, so now you remove B from here. Okay, you have chosen B. You have visited A, you have visited B. Okay, now what is remaining? C and D. Now you add D. Okay, D is the next one, right? Connected. So C and D will come into place. Now among C and D you have to come. For C, f of C is 5. For D you find f of D. What is f of D? Fast. Tell me f of D. Come
4,
on.
sir. 4.
4? No. F of D is not 4, na? G of D is 4. Right? G of D is 4. The distance traveled till now
Acha, total. Acha, sir.
is 4.
Of it.
Okay. And then
Plus 1.
plus
5.
plus h of d,
1.
not
Yes,
this
sir.
one.
5.
Okay, not this one. This is
Acha.
different. This is
Yes, sir.
this is
The top one.
heuristic one. Whatever is comes here, that you have take. Okay, so again this will be 5. Okay,
Okay,
right?
sir.
So once this is 5, what will happen?
Both
uh,
are same. We can choose either of
we
C.
can we can choose either of C and D. Okay, so if let's say, because I chose the number like that, D and C came. Let's say D was clearly better. Then next would have come G.
Yes,
r-
sir.
And if the G has come, what you have to do? Stop. Okay. If you reach the
Okay.
goal, you stop. Okay.
Okay, sir.
Huh?
Means I need to find f of g also. If, for example, f of d I got 4, then I will find f of g, yes, sir. No?
Yeah, yeah. You can find f of G. Okay. But f of for G the heuristic will be 0. Okay. For G heuristic will be 0. Okay. You find f of G, and after that you stop. Once you reach the goal you can stop. Okay, now let's do the other way. Let's, because this was 5 and this is 5, let's choose C. Okay, both are 5 5, right? D and C are 5 5. Okay, so we choose
Yes, sir.
C. We have not expanded D till now, so I am not cutting D. Okay,
Okay, sir.
after expanding, whatever I am expanding I am choosing. Okay, I expand C and I get what? Now I add G. Correct? D and
Yes,
G
sir.
are so what will happen if D and G are there? F of D I have computed. What is f of G?
6 plus 0, 6.
So it will be 6 plus 0, 6. Right?
Yes, sir.
And D का क्या था? D का था 5.
हाँ,
Okay.
sir.
So we choose
D
D.
over G.
We choose D over G. Okay.
Yes,
So
sir.
after D, what will happen again? This only. G only.
Yes, sir. G.
Okay. So what is G?
See
5,
from here,
4,
G
4
5,
plus
5,
4
4
plus
plus
1,
1,
right?
5.
4
Yes, sir.
plus 1, 5. So this, the G that has opened now has f of G5. Okay. So
Yes,
now
sir.
you do this. Okay. So how many nodes did you visit?
Okay, we should count
Okay.
A, B, D.
We should not cut G. Okay. D is there. A, B, C, and D. Okay. You visited this, and this. Okay.
Yes,
and you also visited G because you are going to travel to
Okay.
G. Okay. So here the thing is it is little bit ambiguous whether we should include G or not. Okay. But you don't worry because they have said include the start node and goal node states in your counts.
Okay, sir.
So you don't have to
So
worry about it. Right?
yes, sir.
So yeah. So the path that it will take is A, B, D, G. Right? Because from D you
Yes.
expanded G, not from C. Right? You
Yes, sir.
expanded from G. So, and you can check 1 plus 3 plus 1. Okay, it's 5, and this is 2 plus 4, 6 also. Okay, and also there was a lot of thing about the heuristic also. So, but ultimately you choose the upper path. But you know now how to count the number of nodes you have visited and how to use the heuristic and the distance you have traveled so far. That is g of x. Okay.
Yes, sir. So
Yeah.
now in this example that we have a total of revisited total of four nodes if we count the end goal also. End also.
No, no,
Okay, sir.
you visited all five nodes.
All the five nodes means
You vi
because
for okay, the path
going
has four nodes. Path has four nodes, but you visited all five nodes. You visited C, na? You cut C. See
yes,
here, you
sir.
have cut the C.
Uh-huh.
So you calculate count that also.
Okay, sir.
Okay. Hmm.
Yes, sir.
Any other doubt you have?
No, sir. In this part is clear, sir. Now this
Okay.
I will just try the bigger. This one, the one which we have is slight bigger one.
Yeah,
I
and
will.
you do this for other algorithms also, for breadth
Yes, sir.
first and Dijkstra everything. You do this. Okay, if you get a grid, you convert it to graph, and then you have to do this because in exam, what they will ask is need not ask only A star. Okay, so that I would tell. And yeah,
Sir, this part means in initial weeks doubt is there, sir. Actually, I am not this mechanical ones. I am not much
so you tell,
comfortable.
ask the doubt, na? What doubt you have?
So, sir, actually, when I am assigning the coordinates for the joints, means
Okay.
if we take a four joint manipulator,
Hmm.
so we always take the one which is rotating as z axis, and accordingly we should move forward, sir.
So you okay? I will try to explain, but you can
Sir,
go visit my TA session, YouTube videos for that particular week. And
it's a
there I
week
have,
12, sir.
I don't remember the week number, but
Yes, sir.
my YouTube channel, you know, na?
Yes, sir. In this
Huh,
Excel only, sir.
huh. So you visit my that link in that couple of weeks I have solved
Sir.
those question. Okay, but I will again tell you, okay, little bit.
Sir, sir.
Uh, okay, so let's say I will take a simple example. Here there is one thing, and then there is this another thing. Okay, there is only two link. So what we do is the first step is okay, you put the z-axis along the joint always.
Yes, sir.
Okay, so this you put as z0 and this is z1. Okay, second
Yes,
step is x0 you can take anywhere. Let's say you took x0.
sir.
Okay, then what you do is you take x such that the common normal to z0 and z1, whatever is the common normal. Okay, common normal means what? Perpendicular to both of them.
Both the axes, yes, sir.
Yeah.
Both.
Like that, you have to take what? You have to take x1. Okay. So x1 will be the common normal of z0 and z1. So like that, you take x1. Okay. And after that, what you do? Y you have to take by right hand rule.
Ten
Okay.
guys, yes,
Huh.
sir.
So what it
Yes,
will
I
be?
only. Uh,
It will be y1 downwards because this is like this, and x0 will be so you if you
I,
look at my TA session
I will visit.
video.
Sir. Actually, I got clarity recently. Some lectures and some assistance from this type of doubt sessions. So I I have got only this. I just reconfirmed it.
Yeah,
Ki,
yeah, yeah.
as I'm thinking approach is correct or not.
That, yeah, yeah, like that only.
Only this.
And in that, I have also given some snippets from a book,
Sir,
so
yes, sir.
it is step by step.
And,
So you can go.
just
But here I have done, so you know, you can tell.
so, sir, actually, this wordings in this actually, when we calculate some parameters like d alpha at that
Yeah, yeah.
time,
Hmm.
and some wordings called coincided,
Yeah.
translated. So
Huh.
these wordings are also bit. All these words similar, or these wordings also we have.
Yeah, yeah, yeah. So those wordings, na, those wordings,
I will,
I don't follow those wordings. If you
sir,
see
sir.
my lecture,
I will just go through
okay,
those, sir. Actually,
yeah,
okay,
you
sir.
go through that because I don't follow. It will you will be able to do it easily after looking at that. And I have also given some YouTube lecture links of
Acha,
some tutorials also. That also
sir.
you can look. Okay.
Okay, sir. Okay, sir.
Okay. Any more doubts? Anyone? Sujay, do you have any doubts?
No, sir. No doubt.
No doubt.
Uh, sir, only one left, sir. Actually, means we when we say about Markov model,
Hmm.
we only consider just I confirm the one small confirmation. But means we only take the previous state. No, sir, we don't take the before states. We only
Hmm.
consider previous states.
Yes. Yes.
Uh,
Not
so
previous
next,
states, just one state previous. Only one state previous. Not all the previous state.
uh,
Only one state previous, not all. Okay, so you solved the traffic signal question na in the assignment.
yes, that time, now I just watched that videos and
So in
and
the traffic signal question, we have to just look at
uh,
the previous state only. If you know it is red signal, okay.
yes, sir.
After that, what you will be getting? Green only or orange you will get, right?
Uh,
First orange you will get, then you will get green. If you have green, it is not going to become means directly red or something. So there will be some logic to it. That was the question. Okay, so that way it had to be solved. Or for example, if you are a robot, you have a robot, then your current state plus your input, whatever you are giving, you will
previous.
get the next state.
Okay.
Okay, so like that. Anything more? Hello. So I got
Yes,
disconnected.
yes, sir.
Hmm.
I was saying ki we will consider particle filter also in the Markov assumption only, sir. Particle filter.
Yeah, yeah. You can consider that in the Markov assumption, but with particle filter, yeah, you can do that.
Okay, sir.
Markov assumption, yeah, you should be able to do.
Okay, sir. That's it, sir. Thank you,
Yeah,
sir.
yeah.